Good morning. My name is Eldrin. I'm from Biotech.
My name is Erica. I'm from Biotech.
My name is Natasha. I'm from MCG.
I'm Maurice from MCG.
We'll take you together with us on a ride to understand physics is actually all around us, even in biotechnology and mathematics computer graphic field.
In this video letter, we will explore a few physics concepts that are applicable in both fields.
For starters, we'll talk about how rotational motion is applicable in the field of biotech. Rotational motion are actually present everywhere in our daily life, whether it is from our tires spinning, or the earth rotating around the sun, or the electron spinning around its atom. So, to put it simply, rotational motion is actually used to describe the motion of an object traveling around its circular path in a fixed orbit. So today in the lab, we're looking at one of the most profound equipment in our lab, which uses the concept of rotational motion, which is the centrifuge. So the main function of this centrifuge is actually to separate biomolecules based on the concept of sedimentation. So how does it work? So when the centrifuge is spinning very rapidly, it generates a very high velocity. This creates a centrifugal force and a centripetal force, which causes the biomolecule inside this solution over here to separate, because it can induce a gravitational pull inside the solution. So this can cause a separation of biomolecule. As you can see over here, I have a tube. So inside the tube, there will be solution and our biomolecule. So when the denser particle, through the induced gravitational pull, the denser particle actually flow away from the wall, and the less dense particle will stay closer to the center. So this is called the wall effect. As time passes by, all the particles actually sediment down, which is called sedimentation. This can create two layers, which is the supernatant and the pellet layer. So this actually helps us to separate molecules like cell, organelle, and even protein in our molecular biology research. So as you can see over here, these concepts aren't just theoretical. They actually pave the way to the advancement in the diagnostic, therapeutic, and even industrial biotechnology. Thank you.
Have you ever wondered how to keep the laboratory equipment completely safe for harmful microorganisms? The secret lies in understanding the concept of energy in thermal processes used for sterilization. We know that water has a very high latent heat of vaporization, so we can utilize this concept to kill microorganisms under extreme temperature. Sterilization uses heat, either moist heat or dry heat, to kill microorganisms by denaturing their protein and cell wall. In the laboratory, autoclave are the main player. Why? Because this machine uses steam at temperature of 121 degrees Celsius along with high pressure to transfer thermal energy and effectively sterilize equipment here. This heat will destroy top germs like bacteria, viruses, fungi, and spores. This process will ensure effective sterilization, maintain product safety, and prevent cross-contamination, which will ensure success of laboratory experiments.
Have you ever wondered how a liquid behaves when it splashes into a cup? Well, in real world, liquid splashes are influenced by physics principles such as surface tension, viscosity, and gravity. In this simulation, when the circle of water hits the cup, it spread out in a realistic splash pattern. This behavior is governed by the Navier-Stokes equations, which describe how fluids move based on forces like pressure, velocity, and external influences such as gravity.
Notice how the water flows smoothly along the edges of the cup before settling. This is due to the viscosity, which determines how easily a liquid flows. This simulation was created using Blender's fluid simulation tools, where the properties like the liquid's density, viscosity, and gravity were adjusted to achieve realistic effect. Fluid simulation combines physics and computer graphics to create stunning visual. With tools like Blender's or Unity, anyone can experience and create realistic water effects. Give it a try and dive into the world of simulations. Finally, we have to come to the end of this video. Thank you guys for tuning in, and
I hope you have a better grasp of how these three physics concepts can be applicable in both biotech and MCG.
remember to stay curious.
Peace out.
Bye!